Question 12. Here are the first 5 terms of an arithmetic sequence: 4, 9, 14, 19, 24. Part A, find in terms of n an expression for the nth term of the sequence. Okay, so what we're going to first do is work out how do we get from one term to the next, so the term to term rule. And the term to term rule is actually add 5. Okay, every time to get to the next term, we're just adding 5. So actually, if you think about it, it's very much like the 5 times table. The 5 times table is the times table 5n. It's very similar to that. So it's like 5 times table: 5, 10, 15, etc. Now, if you compare the 5 times table to what we actually have, it seems like the sequence we have is always one behind the 5 times table. So it's 5n minus 1. Now, another slight shortcut that you can sometimes use with these problems is if you look at it, it goes 4, 9, 14, 19, etc. You know it's 5n. If you go back a term, what would the term before be? It's going to be negative 1. So 5n subtract 1 is going to be your nth term. Next part, it says here are the first 5 terms of a different sequence. So here's the sequence, looks like an odd one, and it tells an unusual, should I say, I don't mean odd in a mathematical sense. It says an expression for the nth term of this sequence is 3n minus n squared, and it says write down in terms of n an expression for the nth term of the sequence whose first 5 terms are here. So what we're going to have to do is compare. Let's have a look. What do we notice between the terms that of the sequence that we're given and what we're trying to work out? So we know that this sequence here is 3n minus n squared. And look at what's happened. Every term seems to be double the terms that we have here. So if I times that by 2, I get 4, times that by 2, times that by 2, I get 0, and so on and so forth. So it's actually the exact same sequence. It's 3n minus n squared, but actually it's double it. So I put a 2 outside. 2 lots of this expression is this sequence here.